Absolutely. So let me go ahead and share my screen here. A little bit about me. So just while I'm doing that. So one of the core maintainers, also a director of product management at VMware. I'm also heavily involved in the Kubernetes community. I'm one of the chairs for SIG Windows, and I've been that for a very long time now. So I'm fairly intimately knowledgeable around the cloud native space, the investments that we're making across the board, and also fairly involved in a lot of the different cloud native products that VMware is delivering to our end users and customers. Feel free to keep this as interactive as possible. I want to, I'll give you guys as much knowledge on Harbor as we need to, and we'll deep dive into scenarios from there. So let me get started here. So Harbor is a cloud native computing incubating CNCF incubating project. It was donated last year in the end of summer, and it became an incubating project at KubeCon Shanghai last year in November. It already has 8,000 stars, and literally it wasn't too long ago where we only had 7,000 stars. So we are growing fairly rapidly. In a nutshell, Harbor is an open source cloud native registry. We think of this as the enterprise registry, something that you deploy and deliver internally within your organization. And some of these big advantages is that it not only stores images, but signs images, scans them, and allows you to establish your security footprint and your compliance footprint in your organization as it relates to container images. Our mission is to provide the repository for all your cloud native assets. Today, it's container images and Helm charts. Tomorrow, it might be other things. Maybe CNAP bundles take off and become a thing. Operators are starting to pick up a lot of steam. So we want to be the repository that allows you to serve and manage all of these different cloud native assets, starting with container images and Helm charts today. When you look at Harbor, we kind of segment our features into two specific areas. The first one is security. This is really where we shine. We do a lot of things around project isolation and policy. So we allow you to segment your entire registry into individualized projects that you can deliver to different areas of your organization, whether they are development teams or different business units, or even different companies outside of your org. And you can define policy around those projects that allows everything to be controlled, from where should this project be replicated? What kind of scanning and vulnerability analysis policy do I want? Do I want to enforce content signing and validation? All of those decisions can be made at the project layer. So if you're a company that wants to operate internally almost as a service provider and say, I'm going to deploy in the central IT organization Harbor, and I can define that policy and deliver Harbor as a self-service to different areas of my business unit. Second part of Harbor is management. That basically is where we do everything from identity integration, role-based access control, and we support UAA, we support LDAP, we support OIDC with our latest release. So you can bring your own enterprise identity and get single sign-on within Harbor. We also do a lot of things around replicating instances of Harbor or areas of Harbor with other registries. And that's actually a big area, and I think that's where Stephen Wong really came into saying, hey, this really could really work for the branch office, because you could actually set up a project internally within your own private data center and scan all the images you have, enforce content signing, do all the analysis you need to do to make sure that those images are good, meet compliance, meet security demands, and then replicate those images to the branch office where they don't have to do any of that work, because it's already been validated by your main Harbor instance in your data center. And all you're doing at the branch office is serving the images for usage. So all you need is a small pipe to be able to transfer the delta of the images. And then from there on, be able to serve them to your runtime of choice, whether that's Docker, Kubernetes, or something else. We also have a fairly extensible UI and API. Our entire UI is built on top of a RESTful API. And more importantly, Harbor is multi-tenant. So that bring your own identity and single sign-on I mentioned earlier really works well in a multi-tenant environment. I'm going to show you guys a lot of these things in a demo as well. When we look at the architecture, and we don't really need to spend a lot of time, all of these different areas of Harbor are componentized from the signing, the vulnerability scanning, the vault, our database that contains a lot of the metadata and configuration of Harbor, to the actual registry, the identity providers, and most of these components run as Docker containers. So whether you deploy Harbor in Docker, you're going to get a whole bunch of images that are running the different components of Harbor, or you could deploy it using Helm in Kubernetes, and you get a scalable architecture where most of these components run as pods. And forgot to mention, at the underlying layer, we have local or remote storage. So we support NFS, we support S3 compatible storage, or you can use local storage, wherever Harbor is hosted, to kind of host your repository. So if you want a scalable or infinite capacity, you can use an S3 compatible storage, and we work very well in terms of pushing our content there. Harbor 1.8 was our latest release, and we shipped that at the same time as KubeCon Barcelona a few weeks ago. And we actually had some really specific capabilities that we enabled that advanced our vision in some of the areas I mentioned earlier. The first one that we enabled was what we call robot accounts. Today, when you enable identity federation of Harbor, whether that's Active Directory, LDAP, or OpenIDC Connect, one of the difficulties that you have is when you start executing CI/CD pipelines, you don't want to provide your enterprise credentials into the CI/CD pipeline. In fact, during the community meeting for Harbor earlier today, one of our users basically really applauded us on creating robot accounts because he doesn't want to put into his Concors and pipelines his enterprise creds. It just doesn't work. And more importantly, even if he was able to put his enterprise creds, if you're using tools like Docker Client or Helm Client, they don't know how to do the authentication dance and federate your identity to their backend system. So for all those scenarios, it's great to create a robot account that has a limited time to live, where you have to refresh its password, and you get a username and a password that you can set up for CI/CD. So simplified consumption, make it easy for users to integrate Harbor within the bigger umbrella of services and tools in a cloud-native world.
Quick question on the robot accounts. If you're running Harbor in Kubernetes, can those just be Kubernetes service accounts?
No, it is still an identity managed by Harbor.
So you don't have the ability to kind of federate to the cluster itself for identity. Okay.
Not today, but that's something to think about. Essentially, that would mean is that you have to run the container that manages the robot accounts as a service account, and then kind of federate it from there. It would involve a little bit more planning to get that to work, but not entirely impossible. On the OpenID Connect front, that's something that we added very recently, so you can have support for Google accounts, DEX, and Ping identity. So now you can use OIDC for federating into additional providers. And then we added a couple of things around health check API and stability and reliability fixes. So we're kind of improving how Harbor can be monitored for production workloads. And as more folks are scaling Harbor within their organization, the need for some of these additional capabilities is important to be able to run in production. And in the replication workgroup, before 1.8, you could only set up replication, so you could replicate from one Harbor instance to another. So Harbor to Harbor worked very well, but we didn't have any other capabilities. With 1.8, we added the ability to replicate from Harbor to Docker Hub, to any other Docker registry, as well as to the Huawei Cloud registry. So now we added 3 additional replication targets, and we have a working group that already is adding things like AWS, Target, GCP, Azure, and a few others. So we are expanding that work so that you can replicate Harbor to a multitude of different providers. And our replication is both push and pull. So it's, even though Harbor is going to initiate some of the replication, we can also pull or push content from those providers.
A quick question. So is this the, what we call like content replication next generation as a proposal I saw in the Harbor Wiki? It was basically allowing non-Harbor replication, right?
That's correct.
How do you deal with the canonical image name if the canonical image name had a host name of a different registry? When you do replication, do you strip the host name and use the Harbor instances host name and just keep the image tags and name intact, or?
Yeah, that's right. So if they have a namespace attached to it, we'll strip that and we'll add the project that you have in Harbor as the namespace now.
Okay, so when you reference image names in like PodSpec, you have to, if you want to move a pod from referencing an image on another registry to the Harbor registry, you've got to update the image name to point to the Harbor path.
Yeah, you update what your repository will be, but your image, the repository name, which is basically, and then you have your tag, those will stay intact. So your repository and your tag don't have to change. So if you have, for example, Redis is a repository, and then version 1.5 is your tag, those don't have to change. What would change is the namespace, as what Docker usually calls it. So it would either be the namespace in Docker Hub, and it could change to the project name in Harbor.
Have you looked at masquerading that somehow, so you can have Harbor masquerade as GCR or Docker Hub or something?
We haven't done that. The problem is some of these replications are tied to a project, and the project name kind of becomes a namespace in the Docker registry environment. We can look at that. That's a good idea to think about. I can ask some of our guys to see if we can mask that. The problem is that your original namespace might have a conflict with something that someone else already created in Harbor. So that always will bring up some issues, because then we wouldn't know where to route you.
I have another quick question. So for the image replication, the image story is hierarchical, or you support peer-to-peer replication?
It's a peer-to-peer replication. You're replicating specific assets from A to B.
Okay.
And you can set up as many replications you want, so it can become almost like a tentacle. You start from one project and you replicate to 3 or 4 areas.
Mm.
And then those areas could replicate somewhere else in extent. So you could make it hierarchical if you wanted to, but it's not built by definition that way. So you could replicate A to B and B to C, and that creates some form of hierarchical replication.
I see. Thanks.
So kind of looking at where we're going with Harbor, we just basically finished our planning for 1.9. And as part of that, we're basically making investments on 1.9, 1.10, 1.11, which are, think of them as 3-month bounded releases, into a couple of areas that we again have split off into 2 different swim lanes. And I don't want to spend too much time on this, but I'll kind of give you guys a high-level overview. So on the management front, we do want to have a Kubernetes operator for Harbor to simplify management, consumption, and operations of a Harbor installation within Kubernetes as a native Kubernetes application. Going down the theme of making it easier for companies to run Harbor almost as service providers, we want to do things like quotas and time to live for images, and have an operator of Harbor define both resource constraints as well as compliance needs on a project basis, so they can both lessen the amount of resources they're using within the project and only keeping what's absolutely necessary, but also at the same time meeting any regulatory constraints around image creation and their amount of time that those images are floating around within your enterprise. We're doing a lot more things on metadata management, making it easier to search, tag images, group them together, and kind of expose that to additional functionality like replication, so you can use metadata-based replication. We are going to add the login endpoint for so we can have a sync resource for Harbor, so we can have integration to FluentD and Splunk and other tools that use that basically can take in a sync resource. We're also expanding our preferred scale. We actually have our biggest customers has millions of container images in production of Harbor and many, many nodes across obviously multiple installations of Harbor. But we want to continuously invest in, how can you have more images under management? How can you have more projects into Harbor? How can you have more users simultaneously pull and push images? All of those are things that we're looking into improving. On the extensibility front, something that we wanted to deliver with 1.8, but we were not able to, is webhook support. So we're going to start with a minimal viable product on that in the 1.9 release, and we're going to have the ability to subscribe to events around image and home chart upload, download, deletion, as well as all of the CVE and vulnerability scanning related webhooks. So, hey, I did a scan and I found a CVE, or I did a scan and it was successful, or I did a scan and it failed. So you'll be able to get events around this and either drive notifications within your enterprise or even create some automated remediated actions around this. Today, Harbor has static analysis, and we use Claire underneath the covers to do our static analysis and vulnerability scanning. But we want to expand on that and create a bigger umbrella of what we call the interrogation service, where scanning using Claire is a first-class citizen of that. But also we want to expose that to additional companies and vendors that want to come and add value on top of Harbor. So you can think of an enterprise saying, hey, I want to build my own plugin for the interrogation service that does a license check. It's just a simple license check that my developers are uploading images and we enforce certain licenses. Or maybe something more advanced where Aqua Security comes in and implements this interrogation service to do their own scanning and vulnerability analysis on top of what Claire provides.
So do you see container analysis as being something adjacent to Harbor or inside Harbor? In other words, in terms of the scoping, like is this a complementary set of services that sit adjacent to Harbor or inside Harbor?
I think it's both. I think at the base layer, having something that what Claire provides using static analysis is a fundamental part of a container registry for the enterprise that where we tout it as a secure, compliance-based registry. But then you can add all these other complementary things where we can extend Harbor being the source of truth for your container images and allow other vendors and other companies to come in and add value add on top of it in a complementary basis.
Right. Yeah, I'm just trying to think, because everything is connected. Everything. So in terms of boundaries, right? Like you could sort of say that because this is about container source of truth, and there should be CI/CD inside of Harbor, or like all the container building could be inside Harbor. Like everything you could put in the bucket, right? But where do you draw the lines and say this is the focus, this is the specific focus for Harbor versus where we integrate, where we build integration surfaces?
Yeah, I don't think you'd want to build a monolith. One of the ideas we kicked around in Barcelona after our IoT and Edge meeting with Kilton, who isn't here today, but we had this concept of Harbor being in a position to know when a new image has been pushed. And we could take one out to this sidebar service that would stand it up in a honeypot and do not static analysis, but go instantiate the container and watch it like a hawk to see if anything funny is going on. And then if something's detected, report it back. And you might want Harbor to be the place that consolidates all of these security related reports, even if it isn't doing all of the scanning operations itself.
Yeah, no, I mean, if all the systems are evented and instrumented with events, that's ideal, right? Because then you can integrate all these events how you see fit.
And that's exactly what Steven mentioned is exactly the approach we're taking with Aqua. You push your images to Harbor, Aqua Security comes and pulls the image, creates a fingerprint out of it. They scan it, they basically do everything that they do within their proprietary engine. And then they just do a report back to Harbor telling them, hey, this image is safe or it's not safe or not yet. And that's the model that we want to go to. So some base functionality will always be there in Harbor for the guys that gives them the minimum bar of securing their images for their organization. And then from there on, we want to expand it to value-added services that we could think of. Then a couple of other things, proxy cache and P2P distribution are things that we're working with partners to enable. Think of things like Project Kraken from Uber and Dragonfly to improve the cold start of images. So I think that in an IoT and edge scenario where you don't have a lot of bandwidth, doing P2P and is going to significantly decrease the amount of bandwidth that you're sending around, and also potentially improve the cold start time for containers that are new that need to be pushed to the edge. And the last, today we support images and home charts only. And I kind of mentioned earlier that we want to do more than that. So as the cloud native community moves to additional artifacts that are necessary to host your runtime container images or anything else, we'll look into expanding Harbor in those areas as well.
One of the things, Michael, that's come up in this group before is the idea of potentially hosting device firmware and things that are not containers but still binaries. And really, I think if you look at something like Harbor potentially as a cataloged blob store, maybe that isn't an outlandish thing to entertain.
Okay, I wrote a note on that. I didn't think about that. So I know, things that I had in my list, starting from operators, obviously, and CNAP bundles, what are PMs, Word files, other things are scripts that are very important in the community as you need them. Specifically, even CNAP bundles require them to kind of formulate your apps as they're running in production. But device framework might be something important as well. So basically, you'll be using Harbor as the FTP server or the repository at your local edge. All right. So that's it from where we are. I don't need to go into into some of the other slides other than just saying Harbor community is thriving. Ever since we got into CNCF as an incubating project, and ever since we've been donated to CNCF in August of 2018, you can see kind of our contributions, both from a company as well as developers, has been growing. And we're seeing more and more people coming into Harbor and contributing. And in fact, 1.8 was our release that had the highest number of contributions across the board from different users, different companies. And it was an incredible thing to see all these people coming together and building an open source cloud native registry. If you guys want to reach us, this is a slide that talks about where to find us on CNCF list, on Slack, Twitter, GitHub, as well as we have a demo environment that you guys can use to kind of take Harbor out for a spin. So that's it from the slides. Any questions before we kind of go into a little bit of a demo as well?
Now let's see the demo.
All right, cool. So let me kind of give you guys a high-level overview of Harbor, and I'm not going to go into a super long demo, so I can give you guys the opportunity to ask questions and kind of get into a discussion. So this is Harbor. This is a Harbor 1.8. It's installed on AWS in this specific instance. If you go under the projects, you get some high-level details around the amount of storage you're using, how many repositories you have, private versus public, different projects that you have. And you can see here I have a CNCF project, I have my Go Harbor project, and a library project. And I'll show you guys more details as we deep dive into that. We have logs, so you can figure out what's going on in your environment. You have your administration where you have users. And in this specific case, our authentication on Harbor is set to OIDC, and I'm logged in as a user that came in from Google authentication. So I logged out right now. So if I can log in back into Harbor using username and password of the system-wide admin, or I can log in using the OIDC provider. In this case, it will redirect me to Google Sign-On, and I can pick one of my different Google accounts, which I have mapped to a Harbor account. So this is my users. Now, one of the big things that we enable to 2.8 is not only robot accounts that I mentioned earlier for CI/CD, but what if me, Michael, I want to use Docker client? Docker client doesn't know how to do this federation dance with Google accounts. So one of the things we enable for me is I can click on my name, look at my user profile, and I have a CLI secret here that I can use for Docker and Helm CLI access. So I can go ahead and copy my password here, and then I have a password that I can use for Docker client commands that's attached to my OIDC federated identity. After users, we have registries. Think of this as different endpoints that I have assigned into this Harbor installation to be able to do replication to other entities. And if I were to create new endpoints here, you see that we have different options. We have Docker registry, we have Huawei cloud registry, we have Harbor, as well as Docker Hub. So all of those are accessible for me to be able to push and replicate images. And I provide some things like endpoint URL, ID and secret, and obviously certificate.
What is the reason that wouldn't be just any Docker Hub API wire compatible destination? What makes that specific to those finite set?
I think it's just testing. We're willing to fully support and back the registries that we've validated. So adding more registries is not incredibly complex, and we're adding them as we are adding support. So I think it's more around, can we commit to support someone, help them should they have an issue against the registry that we have validated to work.
And when you say support, though, as an open source project, what is that? What do you mean by that? Because that sounds more like a commercial kind of support concern.
Yeah, I mean, so we do have to support our users, right? So it's best for support from an open source project, but we don't have infinite amount of resources. So if someone were to try a Docker client that's a different version of the Docker client that we support, and some of the API didn't match, then we're going to have a problem. So any of those things introduce both friction at the customer layer, where they're unhappy with what they're using, and then we will have to invest time and resources to go investigate what's going on. So
sure. I guess I'm asking, like, what does a pull request look like to add one of those? Like if I wanted to add a pull request to add GCRIO, is it just a matter of showing some scripted output of here I'm running a patched version and it works as expected, or is it?
Or maybe you have to add a test case. I don't know how.
We have a few test cases on that. So we have a replication working group. So you could join that validate some of the test cases that they're running on that and submit a PR, and we'll probably accept it, and you move on from there.
Cool.
I think the other question is like, what other APIs look like when you push and pull images and also replicate peer-to-peer, so that at the community people can extend and create their own?
So they're all Docker compliant API, right? So we're using Docker Registry 2.7.1. So it's Docker compliant push and pull. It's nothing proprietary here.
So same thing for the replication?
That is correct. That's how we do replication. So you can push and pull images into your project in Harbor, and as well as we do push and pull when we do replication.
And then when you do the push pull or replication, the RBAC and then the auth is integrated, right?
Yeah, that's also part of that Docker HTTP API, basically.
That's correct.
Okay.
So if I were to look at, go ahead, sorry.
No, I was going to ask on the other side of this, like, do you have in this demo, how is it like the robot accounts that are used in like a pod definition for image pull secrets? How do you correlate, say, a workload running in Kubernetes who has permission to pull certain images? Like I'm trying to follow kind of the root of intent, meaning I have this workload running in this Kubernetes namespace, and only something that should be allowed, that workload should be the only one allowed to pull these containers from Harbor.
That's right.
How are those two kind of things linked with image pull secrets?
So let me see if I got this correct. So you have a workload account in Kubernetes, and you're saying that you want to authorize that to be the only one that could pull certain images. I think that the way that you would tie that is with a specific robot account, and obviously in your pod spec and everything else, you will authorize those container images to be for those using that role-based access control. Would that not work?
I think so. I'm just trying to understand. So if I have, as a user of Harbor, a human user, what is the policy about who can create which robot account? Like, do I get to create a robot account that has basically only my level of access and no greater, or?
You wouldn't do it that way. I think that if you're coming in as a user, you should just use our CLI secrets that I entered earlier that basically associate your own identity with different projects in your access control.
Sure. But like, do I go to my Harbor admin to request the robot account creation, or who has permission to create robot accounts? I guess that's
admins do.
Only admins. Okay, so it's not like a thing where basically I can create a robot account for something that has my role levels or less, but not greater.
Yeah, that's right. The robot accounts have complete access to either push or pull images on a per project basis, and those are strictly for CI/CD. You can think of the CLI secrets are the ones that you would use if you wanted to use your individualized RBAC access. And actually, since we talked about it, I can kind of show that here really quickly. So if I'm in a project and I pick the CNCF project and I come in and I want to create a robot account, what I created, I can call it basically, this is Pistons account. And I can give it either permission for pull or push and pull within this project. It will give me a one-time access to the username and the token. I can copy it, and that's it. I don't have any access of it after that. And it's not associated with the user. It's a project-wide account that gives me full access to manipulate images within that project. And it has a time to live of about 1 month. Go ahead and delete it. It's not good to keep things in recordings with passwords. Going back to the replication, so we could look at a replication here. And if I looked at this one with Docker Hub, so this is replicating Harbor to Docker Hub. It's basically saying, go find everything in the Go Harbor project and replicate only images, not Helm charts, and put them into the Go Harbor destination namespace. So very simple, and you can choose either pull-based or push-based replication across that. So in the push, we push from the local Harbor to the remote registry, and pull, we obviously do a pull from there. And in certain situations, we had customers that created a sync. So you had Harbor to Harbor and set up a replication from A to B and from B to A, and that allowed them to have a complete sync of resources. And then some other things around configuration. In this case, I use OIDC providers. So I'm using accounts.google.com as my endpoint. You have things like SMTP server, system settings, and labels. And then on the vulnerability scanning, you have, the last timestamp that we checked for Claire updates. And you can do updates of Claire both online, as in Harbor has access to go to the internet and pull down the latest databases around scanning, or we have a process which is not super user friendly, but it works, that allows you to have another instance of Harbor that's always updated, get the latest database, and then copy it into an air-gapped environment. So if your branch is more air-gapped, we have a process to enable that. No, so go ahead.
Sorry, I have a question about all of this. Do you guys support configuring this in, say, like your pod spec with environment variables or like a config file? Because I remember using Harbor a couple years back, and a lot of this was, it was purely through the UI. So like from an ops perspective, it was harder to manage. Have you guys landed support for managing some of these things via configuration files or anything?
Some of them are enabled by configuration files. Everything that is in the UI, there's an API endpoint, so you could always enable some of them by API endpoints, but our Helm chart has a tremendous amount of configuration already in it for a lot of these settings of Harbor. So if you're deploying Harbor using the Helm chart, you have a lot of flexibility to enable all of this.
Okay.
And then garbage collection here is the standard Docker garbage collection for cleaning up the layers and images that are left behind as you're patching and creating all the time. So going back to the project really quickly. So if we look at one of our projects here, so I have repositories, which are my images in this case, and these images have multiple tags. I can see the different tags. I can see if they're, if they've been scanned for vulnerabilities, if they've been signed. On the previous page, I could see how many times they were pulled. I can re-tag some of them if I need to. I can copy the digest, copy the pull command if I need to, so I can see what it looks like, and basically see some basic information about these images. So I can click on prod, for example, and I can see the build history and see how this was built, including if I was scanning for vulnerabilities, I could see how that looked like. And if we go back, we have Helm charts, and you see some of the same information, different versions of these Helm charts when they were created. I can dig into individual Helm charts and see specific information, including configuration of these Helm charts and how you enable them. So, and you can see here on the config some of the things I mentioned earlier, that you have a lot of these configuration options for Harbor that are already enabled in the Helm chart, so they can make it easier for you to administer Harbor and kind of automate the deployment and configuration of Harbor.
So one kind of related question that says like, how out of the box easy is it to set up Harbor in an HA configuration? I mean, I think almost every project today has an HA story, but there's often a big, difference between the demo single node instance that you can kind of quickly get stood up, and then HA is possible, but kind of left as a big exercise to figure out how to run the Postgres and the Redis and everything else as HA. Is that a built-in thing, or is it a?
I would say medium complexity today, and I'll explain why. If you're setting up your standalone Harbor, and like you mentioned, it's drop dead easy. Actually, Jonas, that's on the call, set one up for KubeCon Barcelona, and it was very simple, very easy to do. If you want to go set up HA, one of the things that we have not done is that you have to go set up Redis and Postgres yourself outside of our installation in either an HA fashion or not, depending on how you want it. And then you run a Helm chart to basically deploy the rest of Harbor. So when you get to the Helm chart, deployment of Harbor is super easy, but there is some setup and configuration that you need to do on your own before you get there. We plan to simplify that. We just haven't gotten to that area yet. So today we require you to go do some manual config ahead of time and manual provisioning before you get to this.
Is that something that the Kubernetes operator could handle? And is that in the scope of your guys' operator?
It is definitely one of the things that we're thinking in the operator. That's right.
Okay. Also, have you guys looked into supporting any kind of support for Kustomize yet? I know it's sort of a younger project. I know Helm's more popular, but Kustomize is built into kubectl now. I'm just curious if that's something you guys have looked at.
No, we haven't looked at Kustomize yet, and obviously CNAP bundles is another thing that we have to look at, because you can think of Harbor as a distributed app itself as well. We haven't had the chance to spend some time into those yet.
Okay.
I'll add a note here to see if you can get someone to, if anybody's interested from the community, to kind of dig in and report back on what that would look like.
Yeah, for things like Kustomize or Helm, how do you sort of, if one was looking at sort of establishing the full set of kind of all the infrastructure they're going to need to run Kubernetes, choosing between like some sort of Git repo versus Harbor for Helm charts, what would be kind of the pros and cons of choosing to just use Git as the main repository versus Harbor for the chart?
I mean, yeah, if all you had was charts, then you're basically almost coming into a fairly even comparison, because we don't do scanning and remediation of Helm charts. We're just a repository, and we're enforcing RBAC and you know, a replication potentially. Where Harbor shines is if you're also using images, right? So you want a consistent identity and a consistent platform for all your cloud native assets. That's where it becomes where you can enforce policy and create policy on once and apply it everywhere, whether that's images or Helm charts. So I think that's essentially where we have that advantage.
Another project that seems to have some complement and then some overlap is Grapheus. As far as storing metadata about images, is that something you've seen as a potential like hook integration for, as you do some of the tasks through Harbor, that you store some of the metadata in Grapheus?
I wasn't familiar with that project. I'll have to do a little bit more research into that. Grapheus.
Yeah, it's basically a container metadata service for storing things like attestations and things like that.
Okay, I'll do a little bit more research into that and seeing how this could help us. Thank you for bringing that person. So that's basically Harbor in a nutshell. So you know, kind of looping back to what Stephen wanted to kind of bring us into this discussion around IoT and the edge. I think that you know, creating Harbor in this kind of satellite installation where you have a main Harbor where you do all of the policy and enforcement, and you do some of the rigorous activities around being able to do scanning and remediation and signing of all your images, and then being able to kind of push those images out to the edge for consumption could help a lot in some of the remote office, branch office scenarios, and even start bleeding into some of the IoT scenarios, provided they have sufficient capacity, obviously, to run container images and be able to run a compute service there. Also give them the ability to have this attach of a local Harbor. So kind of the viewpoint that I have, specifically more around the remote office, branch office, map to IoT, is that every time you want to put a Kubernetes cluster on the edge, you can also put a small instance of Harbor there that will consume very little resources and then be the target of replication from your main hub, and only push the images that are needed for that branch office and refresh them on a daily, weekly basis, or however your bandwidth requires you to. And that would kind of both enforce enterprise policy with all your images having the compliant requirements that are important to your organization, but also at the same time have accessible images at the edge with a very fast turnaround in terms of them being able to take the latest image and push it to production.
Can you add a little color on what the minimum viable resource would be? I think maybe we talked about this before the meeting, before we started recording, but I know we discussed that maybe a Raspberry Pi is too small, but is a NUC, or what is kind of the smallest viable platform?
So let me see, is Jonas still online? Or did he drop off? Jonas actually took a super simple Intel device to KubeCon.
Looks like he dropped.
And he hosted Harbor on that, and it was more than sufficient to basically do a tremendous number of uploads and downloads on that. So I think super small an efficient device will work. But think about it this way: whatever it is that you need to run your compute profile and your compute workloads, Harbor is going to need a lot less resources than that. as long as obviously Intel based or and not ARM.
Is the ARM issue just the building and testing? Because inherently, I'm not sure what the issue would be.
Yeah, I think it's just more around building, testing, and validating that ARM platforms work well for Harbor. There's no reason for us to know. We don't have any idea right now if it works well or not. We just know we haven't tested, then it's probably not supported.
So is it for lack of resource? It's Philip from ARM here. Is it for lack of resource or is it lack of manpower to actually do the work?
I think it's a lack of resources, and as more and more customers and users are telling us that they want to push Harbor to the edge, the ARM is becoming a priority for them. I could see us investing resources into that and making that a reality.
Okay, because
we're not opposed to that work.
Okay, because in terms of equipment, then probably use resources to that packet or the likes to actually test and validate that. But if it's manpower, it's a different question.
Yeah, Michael, we've had some people from the ARM group show up at this meeting. I don't know if any are on the call today, but they definitely come to this working group.
Yeah, that'd be great. Maybe in another time, if they do show up, ping them and let's connect them to us and see if they're willing to come in and help us make that a reality. And we're more than open to working with them to enable that scenario.
Okay, yeah, no problem. Thanks.
And one thing when I brought up Harbor when we were talking about this idea of kind of on-prem is that I actually ended up going a slightly different direction, which was more of a caching proxy that is still so I put in a little diagram that I'd done in the agenda notes. So basically the idea is that like at Google, we do mirror Docker Hub in GCR, and then you'd also have an on-prem Harbor registry, or maybe it's private, but the idea of the caching proxy would be that in cluster, you run a caching proxy that caches cloud and on-prem and everything else sort of local to the cluster, right? So that it's more focused on kind of operational reliability than it is on management and authenticity.
Yeah, sure. Yeah,
and
I think
I felt from the kind of IoT use case point of view, it was more about this idea of intermittent edge connectivity problems than it was about the full kind of lifecycle management that Harbor offers.
I think that you kind of hit the nail on the head there. And things like proxy cache is specifically designed to address the, hey, I don't have connectivity right now, but I still want to have access to all my images so that I can, basically my business can still go on. And I understand that that's huge in the IoT community because you don't have the expectation of always full on 100% bandwidth.
Yeah, I think also from a network bandwidth and then like a latency perspective to intelligently routing to the right registry, right?
Yep.
If you wanted to do this proxy cache, is something like that already an internal component of Harbor so that you could perhaps have a build that strips out unneeded elements and resulting in only a proxy cache?
Not really, but as we're looking to implement proxy cache capabilities ourselves, today you can kind of sidewise do it, with a local instance of Harbor that kind of basically replicates everything locally to the edge. But we're also looking to enable a true proxy cache capability, maybe not next release, but the one after.
Yeah, I posted in notes the Docker container that I'm using as a basis of a solution that I'm, it's a pure Docker entry, but what I'm doing is basically taking that container and then making a Kubernetes workload out of it so that the cluster local cache uses Rook and Ceph, and then basically you have to configure each node in the cluster with this kind of to trust this man-in-the-middle proxy. And the advantage of that is that you don't have to change any image names in your workload YAML. Right? So whether the YAML is referencing a Docker Hub project or a Harbor project or anything else, the proxy is transparent. So it will basically not require any modification to the actual application workloads.
Yeah, that's a huge advantage of that in that area. You're right.
I have another question. So, Michael, you earlier mentioned about health monitoring. Is that still in progress, or because for the push and pull earlier you demoed, like, is there a way for me to either query API or see the progress, whether it's finished, how healthy it is?
So we have health metrics that you can get a metrics around the entire health of Harbor itself. There's no I think what you're looking for is a job kind of object where basically I'm pushing a huge image. I want to know the progress of that. Yes. That doesn't exist, but we will have webhooks so you get a notification when your image is basically delivered. Mm-hmm. So you do that with our 1.9 release.
Well, like for replication, I'm trying to. I don't know enough of the details off the top of my head on the Docker Hub APIs, but you get a manifest, right, of all the images and the target, and then you're applying your filtering, and then you're working through that list, right?
That's right.
Is there a if you have a failure mid replication, does replication start over, or does it try to have like checkpoints so that if you have a very large replication task, keeping it progressing, right? If you've got some sort of poison pill type image name that triggers a bug, that you could kind of keep getting halfway through, right, and then failing. Is there? I don't know if Cindy, that's what you're asking for, but like basically the overall replication health, like, are we running into problems with this replication target, and something should be looked into?
So we have a few bugs where our replication didn't necessarily keep going. So we're working on some of those to kind of address specifically the scenario you said where something failed, keep going with the rest of the images. So we're looking to address some of those. I believe the devs may have already fixed that. But in general, there are events on replication itself. Replication itself has its own event-based system for success, failure, and status. So we have the ability to kind of give you that insight into it. But we do need to do better around when failures happen in terms of how we proceed and how we adjust those, specifically when you have a huge replication target.
Okay. So the other question earlier you mentioned about the secret for the Docker client. Do you provide API for the Docker client, like similar to the CSR? You basically make a request, then pull down the secret, or do you like always go to the UI, get it, and then store somewhere? In that case, do you renew it dynamically, or how do you do that?
Yes, so you can generate a new secret from the UI. So both robot account and secret. Robot accounts expire, but you can always regenerate them. And CLI secrets, you can regenerate it at whatever cadence your organization has. We don't have a custom expiration policy yet, but we are looking to add that as well.
Yeah.
But at the Docker client side, it's static. So that so you could, I think it's very complicated, but you could actually add, I think Docker client now supports like a auth helper as a process. You could actually do your full OI/CD OAuth sign-in flow through Google with a refresh token, and then have that be a dynamic Docker client secret to Harbor. So you wouldn't have to go back to the Harbor UI, basically.
But how would Harbor recognize this secret?
Because it's based on the client ID and the signer and issuer of the OIDC token. So when you configure Harbor, you're configuring it to trust an issuer and a client ID.
You're coming in to Harbor using that Google identity, not necessarily as a CLI secret. That's basically what.
Right.
Oh, okay, I see.
That's kind of the difference for that. So you're basically using Google to do your authentication dance.
Okay.
Well, thank you, Michael. That was great.
No problem. You guys are welcome. This is a great discussion. I took a couple of notes here that I want to go back and address and see if we can make some headway there. And you guys gave me some valuable things to think about. But thank you for giving me the opportunity to come in and chat about Harbor.
Yeah, thanks, Michael.